Welcome to our discussion on predicting the products of double replacement reactions. This time, because of some differences with single replacement, we're going to have to look at a few different things in order to figure out what the product should be. So in this case, it is easier to make the switch right away and then kind of make sure that all of our charges match up. So we know that the pattern is that the cation and the anion will trade partners. So what's bonded to what simply flips. We have to make sure we consider the charges of the cations and anions to make sure we have the right formulas at the end before we attempt to balance. So what I'm going to do first is write all the charges, just for reference this time, above the ions in the formulas. Sodium makes a +1 charge. Nitrate makes a -1 charge. Magnesium is a +2 ion, and individual Br ions are -1s. That's why there are 2 Brs bonded to this magnesium. So what I'm going to do right now is, right now the Na is bonded to the NO3, and I need to trade what it's bonded to. A positive has to bond with a negative. That means that I'm going to need to bond the Na+1 with the Br of the other compound so that I still have an actual compound. Given that I have a +1 and a -1, that means my formula will simply be NaBr. So now, since I've used the sodium and the bromine, I have the magnesium and the nitrate left. Mg is a 2+, NO3 is a -1. That means I'm going to need 2 of the NO3s to cancel out the +2 charge. So I'm going to get some of this extra work out of the way so we can finish by balancing. Alright, so right now I see 1 NO3 over here and 2 over here. So I am going to put a 2 right there. That will solve the NO3, and that now gives me 2 NAs. So I'm going to go over here and put a 2 by this sodium, which gives me 2 Brs, which is good because that finishes the 2 Brs on this side. Notice that in the final version of the reaction, I have not included any charges or any of that work that I did to help me complete the process. I got rid of that to show the clean, balanced equation. So we'll finish with our second one. Make a little room here. Here Ca would make a +2 ion. Chlorine is a -1 ion. Lithium is a +1. And sulfur is a -2. Remember that I'm getting these from what column they're in on the periodic table. Calcium would now have to match up with the sulfur. So I've got a +2 and a -2. Those cancel out. Then the chlorine would have to bond with the lithium. Li is a +1. Cl is a -1. They cancel out. Last steps, I'm going to erase my extra work here. And then I see that I have 2 lithium and 2 chlorine, so to balance this, I simply have to put a 2 in front of the lithium chloride. Next steps, download the document with the practice for predicting the products of double replacement, predict the switches, check your charges, and then as always, finish by balancing. Oops, that wasn't written correctly. Finish, not finisb. By balancing. We can never have an unbalanced equation.